Today let us learn about chapter number 5, complex number and quadratic equation. In the earlier classes we had learned about natural number, whole number, integer number, rational and irrational number, and real numbers. This real number we had learned during the class 10. Now complex number. This number will be learned in this class 11. In class 10 we have learned about the quadratic equation. We know that the general form of a quadratic equation is ax square plus bx plus c is equal to 0, but the coefficient of the x square does not equal to 0. Again, we know that for every quadratic equation they have two roots. Then we know the value of the discriminant. The value of discriminant will be given by b square minus 4ac. By knowing this value, we can predict the nature of the roots. The first one is when we find out the value of the discriminant, then we will compare with the 0. The value of discriminant is greater than from 0, that means getting positive number. The two roots are real and distinct. Then second point is the value of discriminant is equal to 0, then the two roots are real and equal. Number third point is the value of discriminant is less than from 0, that means getting negative value. Then we will say that they don't have roots, that means no roots. Again, when we find out the roots of the quadratic equation, then alpha and beta, we will use this formula to get the value of two roots. Let us take one example. X square plus 4 equal to 0. This is one of the quadratic equation, but there is no x part, so we can write like this. Again, x square plus 0 into x plus 4 equal to 0. 0 into x, 0. Then we will compare with the general form of a quadratic equation in order to get the value of a, b and c. The value of a is 1, coefficient of x is 1, the value of b is 0, then constant is 4. Now let us find out the value of discriminant again. By using the value of b square minus 4ac, we replace all the corresponding values b, a and c, then we get minus 16. When we compare with the 0, this value is less than from 0, that means they don't have roots. Root does not exist. If they don't have roots, then let us find out the value of roots again in order to get a complex number. See, the value of the roots will be given by this formula, and all the values we replace and we calculate, and what we get here, plus minus 2 under root of minus 1. Now let me introduce a symbol I in the equation number 1. The value of I is the under root of minus 1. Then when we transfer this square root to other side, then will become as a square minus 1. Then let's come back. This equation number 1, value of the equation number 1 plus minus 2 under the root of minus 1. Say from equation number 1, the value of x is plus minus 2 under the root of minus 1. Then we know that before what I explained to you, the value of I is equal to root over minus 1. This value can be replaced by I. From this we can get the complex number. I indicates the imaginary number. See, now let me define complex number. A complex number is a number of the form a plus ib, where a and b are real numbers and I is the imaginary number. A complex number is denoted by z. During the class 10, real number is denoted by capital R. Like that, a complex number is denoted by z. and a set of complex number is denoted by C. See, for example, let us take a complex number z equal to 3 plus 4i. But in the complex number there is a two part, one is a real part and one is a imaginary part. The number without I, that is the real part, and the number with I is the imaginary part. See, what is the real part here? 3. The imaginary part is 4 with the I. And here also real part is a 5. And what is value of imaginary part? -7. A complex number can be written as z equal to a plus ib or z equal to a plus bi. You can write any one. See, let us learn about the addition of complex number, how to add a complex number to complex number. Let's the z1 indicates the first complex number a plus ib and another complex number is c plus id be two complex numbers, then the sum of z1 plus z2 defined as follows. When we add the two complex number, these are the two complex number we are going to add. When we add the two complex number, we have to add a real part and imaginary part. See, let us find out the value of this. We know that when we add two real numbers, we have to add real parts. What is real part here? A plus C. Then I is common, it indicates imaginary part. What are imaginary part here? B and D, B plus D. See, let us take one example. When we add these two complex number, we have to add the real part. 3 plus 5 plus I is common, 4 plus 6, we get 8 plus 10i. And let us learn about the properties of addition. The first is commutative law. We know that what is commutative law? When we add two numbers, first is 3 and second is 4, this value will be same. That means interchanging their places. The second place will come to the first place and first place will go to second place. And 4 plus 3, if we interchange their places, their answer is same. That is called the commutative law. And z1 plus z2 is equal to z2 plus z1. Associative law. Say, when we add three numbers, addition of the first two is equal to the addition of the last with the first. And 1 plus 2 is 3 plus 3 equal to 1 plus 2 plus 3 is 5. I think you know this. Like that, when we add three complex number, addition of the first two will be equal to the first two with third is equal to the first with addition with the last two. Then additive identity. See how to get additive identity. This is the 5. We have to add one number in order to get number itself. Number itself. In order to get 5, what number we have to add to the given number? If I add 1, 5 plus 1 is 6, not getting the number itself. So what number we have to add here? 0. 5 plus 0 is 5. That means getting the number itself. Suppose in place of 5, 2. 2 plus one number we have to add in order to get number itself 2. That means we have to add 0 again. 2 plus 0 is 2, like that. Here also we have to do same. Any complex number will do addition with another number, and we have to get number itself, complex number itself. That means what number we have to add? 0, or 0 plus z is also z. So 0 is the additive identity of the complex number. Additive inverse. Before doing this one, you try to get from this. See, I take example 5 plus one number we are going to add here in order to get additive identity. What is additive identity here? The additive identity is 0. In order to get additive identity 0, what number we have to add here? If you want to get 0, we have to add here minus 5. Plus minus 5 minus 5 is 0. So minus 5 is the additive inverse. So like that, any complex number will do addition in order to get additive identity. What is additive identity? 0. If you want to get 0, what number we have to add here? We have to take the minus sign to the given complex number, minus z. So this with the negative sign of z is the additive inverse of z. Now let's find out the difference of two given complex number. These are two complex number. Then let us find out the difference of two complex number. Given two complex number, same before what we did, like that we have to solve. When we subtract two complex number, we have to do subtraction the real part, then imaginary part. The real part is a minus c, the plus sign, not minus sign. What is common? I is common, plus sign is starting here, so I is common. B minus D, real imaginary part. See, in this example I'll show you 3 plus 5i minus 2 plus 3i. How to do subtraction? We have to subtract real numbers. 3 minus 2 plus I, imaginary part. 5 minus 2, we get 1 plus 2i. Now again, let us learn about the multiplication of two given complex number. These are two complex number. Then let us find out the product of two complex number. This is the first complex number and into the second complex number. See, when we find out the multiplication of two complex number, we have to follow this rule. First, what we have to do, real parts. Real parts A into C. Then we have to put minus sign. Then again imaginary part. We have to find out product of imaginary part. B into D. Then by using this rule, we will get the real part plus I. In order to get the imaginary part, the real part will multiply to the imaginary part with the plus sign again. Imaginary part of the first complex number will multiply to the real part of the second complex number. By using this rule, we have to find out the product of two given complex number. See, let's take one example here. Let's find out the product of these two complex number. By using this rule, what we have to do, multiplication of the real part. 3 into 2 minus imaginary into imaginary number. 5 into 6 plus I. Then what is the next? The first real part of the first complex number will multiply to the imaginary part of the second complex number. 3 into 6 with the plus sign. Then imaginary part of the first complex number will multiply to the real part of the second complex number. 5 into 2. Then we find out these values and getting minus 24 plus I 28. Like this, we have to find out the value of the product of two complex number. Now we try this again. Then properties of multiplication of two complex number. The first is commutative law. Like before, multiplication of the two number is 2 into 3 suppose. Then interchanging their places 3 into 2, their value will be same. This is commutative law. Z1 into Z2, let's change their places Z2 into Z1. The answer will be same. Associative law, this was we may be knowing. The existence of multiplicative identity. See, for the multiplication, when we multiply, let's find out this 5 into, we have to put one number in order to get number itself. The number is 5 itself. In order to get the 5 itself, one number we have to multiply here 1. 5 ones are 5. Like that, in order to get the number itself 5, one number we have to multiply here 1. 1 5s are 5. So when multiply two number, that number itself is getting here. In order to get the number itself, one number we multiply here 1. 1 is the multiplicative identity. Like that, this is a complex number. In order to get the number itself, one number we have to multiply by 1. So 1 is the multiplicative identity. So 1 is the multiplicative identity of the complex number. The existence of multiplicative inverse. See, let's take one example, 2 into. If you want to get the multiplicative inverse, the answer must be multiplicative identity. What is a multiplicative identity here? Multiplicative identity is 1. If you want to get 1 to the 2, what number we have to multiply? 1 by 2. These two are cancelled, then we will get 1, getting multiplicative identity. So 1 by 2 is the multiplicative identity of multiplicative inverse of 2. Like that, this is the given complex number. In order to get multiplicative identity, the multiplicative identity of the complex number is 1. In order to get 1 to the given complex number, what number we have to multiply? 1 by z. That is the multiplicative inverse of the given complex number z. See, there is one formula to find out the multiplicative inverse, that means 1 by z. This is one of the given complex number. Z is equal to a plus ib. Then if you want to get the value of 1 by z, what formula we have to use? A by a square plus b square plus I with the minus sign of the imaginary number minus b divided by a square plus b square. We can use this formula. Now by taking this example, we try to understand how to find out the multiplicative inverse of the given complex number. Say this is one of the given complex number, z is equal to 2 minus I. Here what is value of a? Real part is 2 and imaginary part is minus 1. Same. Now let us find out the value of 1 by z. We apply this formula and all the values we replace here, then getting this value. Maybe knowing this one, or if you forgot this formula, then simply you can calculate by using the reduction of denominator. See, this is a complex number, z is equal to 2 minus I. Then when we find out the inverse of multiplicative inverse of the given complex number is 1 by z. 1 by what is value of z? 2 minus I. See, you must take as this given number is a minus b to apply this formula. A plus b, a minus b is a square minus b square. So what is given here in the form a minus b. If you want to get if you want to use this formula, a minus b is here. What is lacking? A plus b is lacking here. So numerator and denominator will be multiplied with the 2 plus I. Why? In order to use this formula. When we multiply numerator number also and denominator number also by 2 plus I, then this value is getting here. Then in this part we can apply a plus b and a minus b. If it is matching with a plus b and a minus b, what formula we will get? A square minus b square. What is a? 2 minus what is b? I. 2 square minus I square. We know from before what is value of I square. I square is minus 1. 2 2s are 4, and we calculate, we get 2 plus I by 5. Like this also we can get the value of the multiplicative inverse. Then power of I, the value of I square is minus 1. I cube, how can write I square into I? The value of I square is minus 1 into I. After multiplication we get minus I. Therefore also I square into I square we can write in terms of power 2, because we know the value of power 2 of I. Then we get this. Therefore 5 also, therefore 4 into I, value of I4 is 1. Then like this. I think you can understand, you may be knowing this. Without solving like this, we can solve by using this formula easily. See, this is the general formula. I to the power, if we can put in the form of 4k, 4 into any number, I to the power 4k, the value will become 1. I to the power 4k plus 1 will get I only, and I to the power 4k plus 2 will get minus I to the power 4k plus 3 will get minus I. Sorry, this is minus 1. Now let us find out the above values again here. I to the power 4. See, how can write? 4 ones are 4. 4k, what is value of k? K is 1 now. Now that means we can write in terms of 4k. If we write in terms of 4k, what is value of this? 1. The answer will become 1. Then I to the power 5. We must try to put in terms of 4. 4 ones are 4 plus 1. 4 plus 1 will become 5. We use this formula. Then what will be the answer of this? I. Without calculating, we can put directly. If it is in the form of this, what is the value here? I will get I to 7. 4 ones are 4 plus 3. 4 plus 3 is 7. We are trying to put in terms of 4. Then what formula is missing? It become minus I, like that. We try this values also.